welcome to Two Sample T-Test. I'm your host today, Mr. Kenneth Stirrett. Okay, we'll delete that bit out, don't worry. All right, so guys, let's get stuck into it. I'm going to get the highlighter out. You've read this question, you're quite intimate with it. So there's construction, there's fish before construction, there's fish after. And this person is definitely concerned with, can you see the wording? The mean weight of the fish reduced after construction. So top tip is this. If this person is concerned with the weight of the fish after, it might sound a bit counterintuitive, but the thing that this person's concerned with, the weight of the fish after, that's what we're going to call mu1. Now it sounds weird because mu1 sometimes you think before, but the thing that we're going to measure and the thing that's concerned to us we're going to call mu1. So the after is mu1 and before is mu2. I'm just going to put that there. All right, let's start the question then. So the first one is, what assumptions are we making when we do a two-sample t-test? Well, I'm going to put the fish's weight before, the fish's weight after here. The key assumption is that actually the weights of the fishes in the two distribution follow a normal distribution. That means this test is quite accurate in terms of prediction. If this wasn't the case, then the test isn't as reliable. Okay, so one assumption for the t-test to be kind of accurate is that the actual weights are distributed normally. They follow that particular picture. Okay, so that's one assumption. But there's another assumption, and the other assumption is that the variability of both distributions is the same. And remember, variability is about variance, is about standard deviation. So a second assumption is actually the standard deviation, the measure of spread of weights, is the same. Okay? So the two things, one, normal distribution for both weights, and two, the standard deviation, the spread, is equal amongst the two populations. Those are two key assumptions that make the t-test more reliable. Okay? Right, let's get on to the null hypothesis and the alternate hypothesis. So always H0 for null and HA for alternate. The reason we do that is so we don't get confused with the numbers we've tagged with the population means here. Okay? Now you might be thinking, well, why have you got this mu2 and mu1 here? Surely for the null and alternative hypothesis we can just write in words, and we can. Okay? I'm going to start with the alternate, which is a bit weird, but it definitely says that the weight of fish after is less than the weight of fish before. That's clearly what this person's testing for. All right. So given the fact that I've written it that way, the null hypothesis is always the same for any test you're going to do, two-sample t-test. The weight after is equal to the weight before. Okay, that makes sense. Now the reason why I've got mu1 and mu2 tagged is because the TI Inspire has mu1 and mu2 for the alternate hypothesis. So let me grab now mu1 and mu2 and let's look at this alternate hypothesis here. So the alternate hypothesis is weight of fish after. Now the weight of fish after we called mu1. So mu1 is less than mu2. So that's alternate hypothesis. Now that will help us with our TI Inspire work. So let's switch out to the TI Inspire. I've got it here. I've got the data all loaded up before and after. I'm going to click in space next to it. Menu. It's a statistical test. It's a two-sample t-test. We're going to put data in there. And list 1, well, list 1 matches with what you've labelled mu1. And mu1 is the after. And list 2 is mu2, and that's before. And the alternate hypothesis is what we've written down. The weight of fish after is less than the weight of fish before, so it's mu1 less than mu2. And here's the final key thing. This pooled, this talks about the calculator needing to estimate the population standard deviation and variance. And how does it do it? It puts all the fish together into one group, before and after, and it uses all of the fish to make a prediction for the population standard deviation. So can you see it pools all the fish together? So pooled is yes. Pooled for us is always yes. Okay, there's a few little glitches in textbooks, but for us, for our course, pool is always yes. When we click OK, you will find the p-value here. So the p-value for our particular test is 0.202. 0.202. All right. You can also see a t-value here of negative 0.86. Now, for those of you who like to draw a picture, let me show you the picture that goes with this, and then we'll talk about the conclusion for the test. So on this axis here are the t-values, and the t-values are the test values. The mean here should be 0. Now, we did a test at the 5% significance level, and we're looking at reduced. So here's the significant region. Here's 5%. Okay. So that's our picture for the test. Now, where does our particular t-value for the test fit? Well, our t-value from the screen is t is negative 0.86. So our t-value is down here because it's negative. But where do we put it? Do we put it in the 5% critical region, or is it outside the critical region? How do we decide? Well, the p-value is 20%. So we measure back 20% from the left. So we measure back 20% from the left, and that might take us to about here. So our particular t-value is about here. So can you see that we're not in the critical region or the significant area? So therefore, we've got our p-value of 0.202 is greater than the significant 0.05. Therefore, there's just not enough evidence to suggest that the fish weights have reduced. So what do? We hold onto H0. There's insufficient evidence that the fish have got smaller. Okay, so what we're looking for in terms of being able to reject H0 is a t-value that puts us in that 5% critical region. And that is the two-sample t-test. You're very, very welcome.